Hello, my name is Charles Seaton. I have been involved in all aspects and functions of aerospace design and engineering related to composite materials for over 30 years. Currently, I'm a senior manager at HeatCon Composite Systems Incorporated in Seattle, Washington. Control and recording of shelf life and out time are important matters. Any adhesive or prepreg beyond its specified shelf life should be either retested or scrapped. Time expired materials must be retested for flow and, if necessary, for bond strength before being used beyond their shelf life or time limits. Beyond following guidance described in material specifications, it is important to follow good shop practice. Structural integrity is very dependent on the handling and storage of composites. As pointed out in the study materials, bonded structures created during manufacture or repairs is more difficult to inspect for structural integrity. This makes it even more important to use correct procedures in surface preparation, moisture elimination, proper material storage and handling, and in-process controls to create defect-free bond lines and patches. I'd like to focus on one important aspect of handling composites in an uncured state: the damaging effects of absorbed moisture, which results in the dramatic reduction in strength. Reduced strength occurs with the presence of even a very small amount of moisture in prepregs or adhesives prior to curing the composite part. It works like this. Moisture can migrate to the surface of the laminate during cure, resulting in weak bonds, porosity, or voids in the bond line. Furthermore, formation of steam and honeycomb core as a part is being cured and heated can create additional damage. Moisture can appear through various forms, with the primary sources of this problem including condensation inside of storage bags and through excessive room humidity. As we will discuss, each of these sources can be eliminated by proper shop facilities, procedures, and practice. Very small amounts of moisture at the pre-bond stage of manufacture can cause dramatic reductions in part strength after the curing process. One study shows that the room temperature strength of a 350-degree epoxy resin part with absorbed moisture is only 20% of that part without the presence of moisture. And this was created by allowing moisture to be absorbed at a rate of only 1/4%. So what are some practical approaches to eliminating water damage during the preparation of composites for curing? First, assure that the layup room is humidity controlled, with humidity maintained below 60%. Here is a chart which has been used as a guideline when assessing humidity levels. Second, provide adequate time when drawing material from a freezer prior to use to bring the composite material to room temperature. This will eliminate moisture condensation on uncured material prior to cure. Third, kitting new rolls of prepreg into smaller packages or kits. In production, smaller prepreg volumes organized into kits can be thawed in a shorter period of time compared to waiting for a more massive roll of composite prepreg to reach room temperature. Also, use of larger rolls of prepreg accumulates more out time from a freezer, limiting the usable life of the prepreg. Using smaller kits avoids bringing a whole roll of prepreg to room temperature prior to removal from the storage bag. Regarding smaller kits, distributors often provide small quantities with short lead times to achieve the advantages of kitting described above. For example, a roll may be divided into smaller lengths and shipped to the end user. Here at HeatCon, we pack shipments in dry ice and provide 2 chart recorders with each box. We're able to ship small quantities of prepreg worldwide. It begins with HeatCon receiving large rolls of prepreg from the prepreg manufacturers. Heat gun divides the larger rolls into smaller quantities of prepregs stored in a freezer as shown. The prepreg is then shipped in 5 and 10 yard lengths to the final destination. Absorbed moisture by material prior to curing of a composite part must be avoided. Personnel involved with handling with storage of composite materials must be aware of material specifications as defined by the manufacturers. Following shot procedures to avoid moisture absorption is equally important. This discussion emphasized the importance of proper handling and storage practices, with special emphasis on the requirement to control the moisture absorption by composites prior to bonding. We also discussed procedures and practices used in industry to address the significant issues in order to have sound composite parts with structural integrity.